Hello guys, welcome back to Code. Today again we are solving an interview problem asked in Amazon and Google. So the title says shuffle an array according to the given order of elements, and its description is given as given an array of distinct integers, shuffle it according to the given order of elements. Like as we can see over here, the nums array is 1, 2, 3, 4 and 5, and the original position is of the element 1, it should be present at index 3, element 2 at index 2, element 3 at index 4, element 4 at index 1, element 5 at index 0. So this is its original positions. Okay, we have to arrange it in that order. As I said, 5 at 0th location and 3 at the 4th location. Okay, so this is how we have to arrange our array. Okay, but now how do we perform this? There are many techniques. Now you guys might say, okay, then we can use an extra space of O of n. We can create another array and we can store the elements over there. Yeah, that's also fine. But like when you are paying for FAANG companies or any product based companies, you should have an efficient, okay, even the space complexity should be O of 1 if it's possible. And in this case, yes, it is possible, the space complexity of O of 1 and the time complexity of O of n. So how we are going to solve it? Let's check it out. So over here I've written down the same example. As you can see, this is our array and this are the positions and this is the indexes. So zero based indexing, as I said, it will start from 0 as it is mentioned. Okay, now what our function will do, what our algorithm will do, it will obviously start from the left. Okay, and it will check that if this value matches with the I pointer, this is our I pointer 0, we'll loop from 0 to 4 in this case. Are these two values matching? No, these two values are not matching. So what it will do is, it will swap the elements, where the elements at the 3rd position and the 0th position. Why? The value of our I is 0. Okay, in the both the arrays it will do, even in this array and this array, and it will perform this operation until and unless we have an 0 over here. In this case, means the value of I and the value of position at that index should be same. How it's going to perform, we will see. Okay, what I said, it will swap the elements at 0th index and the 3rd index. Okay, the 3rd index is over here, means this and this, this and this. So here it will be 4 and here it will be 1, here it will be 3 and here it will be 1. Alright, the value of I is not yet changed. Okay, value of I is not yet changed. Why? What I said, here we should have 0, but it is 1 0. No. Now again we will repeat this procedure. We will swap index 0 with index 1 position. Means here both the elements will be 2. Why? Because here also 2 is there, here also 2 is there. Okay, here we write 2, 2, and here we write 4 and 1. Again, yet we have not received our element. Now we will swap 2 with our current index. 2 and 0 will swap. So what is 2 and what is the element present at index 2? It is 4. So I will swap here 2 and here 4. Here comes 2 again and here goes 3. Now 0 and 4 we have to swap, means this and this index we have to swap. Now here comes 0, here goes 4, here goes 5 and here goes 3. As you can see, that this is 0, this is 0. Now we will stop our loop, the inside loop. Okay, first of all, this is a for loop which we are traversing, and inside that the operations which are performed now will be in the while loop. Okay, until and unless the position at that element and the I does not match. Now we will move to the next index. Okay, we come over here. Is 1 equals to 1? Yes, it is equal. Is 2 equals to 2? Yes. Is 3 equals to 3? 4 equals to 4? It means in this case, okay, every time this will not happen. In this case, in one swap only, we have arranged all the positions in its particular order. So this is our final outcome: 5, 4, 2, 1 and 3. Okay, so now let's tweak the example which we had received and let's check for another case. So guys, now we will look at our another example. Okay, in this case it will not happen in a single swap, I guarantee you that. Okay, so again we'll start from our left. This is our I pointer over here. Is the value of this and this the same? No. So we'll swap this 0th index and the elements present at the 3rd index in both the arrays. Means this goes here. It means this becomes 1 and this becomes 4. This becomes 3 and this becomes 0. Oh, now here in the first swap only we have received 0 over here. So now what we will do? We will just move on. The value of I changes. Value of I comes over here. I mean the pointer I comes over here. Now is 1 and 2 the same? No. So what we will do? We swap the elements at index 1 and 2. Means this and this index we are going to swap now. Okay. So how the swapping will take place? 3 and 2. Here comes 4 and here comes 2. Is the index matching the 4 and 1? No, it's not matching. So what we will do? Now in this case, you have to swap 1 with 4. The index 4 means this index. Now here comes 5 and here goes 3. Here goes 1 and here goes 4. Now it's swapped. Now we move to next position. I comes over here. 2 and 2 matching. I jumps over here. 3, 3 matching. 4 and 4 matching. So now it took 2 swaps to complete this. Okay. So in this way our algorithm will work. Let's jump to the code. The code is pretty simple. I will mention it down in the description. So this is our array and this is our positions. Okay, this is the first case which I considered, which will perform only in one swap. Alright, so what I am calling a function arrange, and as I said, this is my for loop and inside that while loop. What is the condition? While the position of I is not equals to I, as I mentioned, this and this should be same. Until and unless that's not same, we will perform the swapping, and even the swapping is performed in an efficient way. If you guys don't know this technique, please note it down. Okay, without using any extra variable, you are swapping the elements. Alright, this is a simple algorithm. Now let's run the code. As you can see, this is the output. Now I will show you guys the swapping part. Okay. So as you can see, this only happens in one swap. Okay. Now I will tweak the positions over here. Now let's see how many swaps it takes. As you can see now here, it is taking 2 swaps. 45213, 45213. This is the output. If you guys are preparing for Amazon or Google, I have created our own playlist which has the latest interview questions which will appear on your top right corner right now. You can watch it, and if you guys like the content, if you guys are understanding what I am teaching you guys, please give a thumbs up. I really appreciate that. It takes some efforts to provide the content to you guys. Subscribe to the channel and stay safe.